we can do the chapter of dimensional analysis, that is how to write dimension and the dimensions of different physical quantity. At first, we go with the 7 dimension of world. What is known as 7 dimension of world? 7 dimension of world. 7 dimension of world. We know about 7 wonder of world, Taj Mahal and many other things, but here we can go with 7 dimension of world. The physical quantity which is called 7 dimension of world, the fundamental quantities whose which sum of combination gives any derived unit is called 7 dimension of world. The fundamental quantities which some combination gives any derived unit is called 7 dimension of world. We know that there is two type of quantity. One is fundamental units which are independent and which cannot be derived from other unit or which cannot be resolved into smaller unit is called fundamental unit. And the unit which depend on fundamental units and by combination of fundamental units they derive is called derived unit. So, the 7 fundamental quantities, the fundamental quantities which some combination gives any derived unit is called 7 dimension of world. Now, what are the 7 dimension of world? What are their dimension? Now, we know in SI unit there are 7 physical quantity, that is, and their dimension is called 7 dimensional of world. First is, we know dimension of length, dimension of length, that is L, dimension of mass M, dimension of time T, dimension of current, that is A, dimension of thermodynamic temperature, thermodynamic TD, we abbreviate as TD, thermodynamic temperature, that is K, dimension of luminous intensity, luminous intensity or simply intensity of light, which is equal to candela small c small d, and dimension of substance, that is mole. 5, 6, 7. These 7 are the 7 dimension of world and the most fundamental quantity in SI unit. In SI unit, you know this. Okay. Now we can go with the dimension. What is called dimension? The definition of dimension. Now we go with definition of dimension. Dimension is nothing but the power or on the exponent at which the physical quantity is raised to represent a definite physical quantity. Okay, I say again, dimension is the power or exponent of fundamental quantities can be raised to express a physical quantity. So, we can go with the definition of dimension. Now, we go with definition of dimension. The power or exponent in which, sorry, in which, not to which is more appropriate, to which a fundamental quantity, that is any of the 7 dimension, fundamental quantity must be raised to express a physical quantity. Physical quantity. The power or exponent to which a fundamental quantity must be raised to express a physical quantity. Suppose if we choose the a dimension of area, this is length into length, that is L square. In terms of mass, length and time, we can write it as m naught L square T naught. So, we can say it, the dimension of area is 0 in mass, 2 in length, 0 in time. We say it in this way, 0 in mass, 2 in length and 0 in time. Dimension of work, that is dimension of force multiplied by some distance. So, dimension of force means force is ml t minus 2, that is mass time acceleration, into distance is L. So, ml square t minus 2. So, we can say dimension of work is 1 in mass, 2 in length and minus 2 in time. 1 in mass, 2 in length and minus 2 in time. In this way, we can express the dimension of any physical quantity. Next, we can go, this is the definition of dimension. Okay. Next, we go dimensional formula. What is dimensional formula? So, the dimensional formula is the dimensional formula is the expression that shows how and which fundamental quantity is used to represent a physical quantity. This is the dimensional formula. Dimensional formula is the expression that shows how and which fundamental quantity is used to represent a physical quantity. Suppose we go with pressure, dimension of pressure. So, the dimensional formula of pressure is pressure means force per area, force per area. We cannot use a equal sign here. If we use a equation, then this is written as dimensional equation, but we can go with dimensional formula. So we cannot put a equal sign here. Force by area, or force is ml t minus 2 by area L square, or that is m L minus 1 t minus 2. M L minus 1, this can be raised as L minus 1 t minus 2. The dimensional formula of pressure is m L minus 1 t minus 2. Okay. And the what is dimensional formula? Dimensional equation. What is dimensional equation? Now we go with dimensional equation. Dimensional equation is written, dimensional equation is written by equating, we have to remove it. Dimensional formula is written by equating any physical quantity to its dimensional formula. Okay. Suppose this is pressure. If we write it as pressure, the symbol of pressure is P, equal to this term m L minus 1 t minus 2, m L minus 1 t minus 2, then this is the dimensional formula. Now here three things happen. This is, if any equation is written as P pressure is equal to m L minus 1 t minus 2, then the dimension of pressure is 1 in mass minus 1 in length and minus 2 in time. What is the dimensional formula? Dimensional formula is only this portion. Dimensional formula is not equal sign, m L minus 1 t minus 2. Okay, and dimensional equation is P is equal to m L minus 1 t minus 2. I hope you understand the difference between dimensional formula and dimension equation. From this we can say any dimensional formula or dimensional equation for any physical quantity. Next we go with some example for our clear vision. Suppose we have to ask for the dimension of Young modulus. So we know that Young modulus Y is equal to longitudinal stress upon longitudinal strain. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . Now strain is a dimensionless quantity. So modulus, Young modulus dimension is the equal to dimensional longitudinal stress. Now stress is nothing but force upon area, that is dimension of pressure. So it is obviously equal to only dimension of pressure m L minus 1 T minus 2. Okay. This is the Young modulus dimension. Next we go with some uncommon things dimension. We know the dimension of area, pressure, volume. I know you know, okay. But here we tell about some complex dimension. Suppose we have to say the dimension of gravitational constant g. What is the dimension of g? Now every dimensional equation can be derived from a expression or from a equation. We know the Newton gravitational formula F, that is force between two mass, is g, the product of mass divided by the distance square between them. So from this equation we can know the value of g equal to, we know, F r square divided by m1 m2, that is dimension of F, dimension of length. We cannot put here the dimension of F. So dimension of F, dimension of length square by dimension of mass square. So dimension of force equal to mLT minus 2 multiplied by L square divided by m square. So we can say the dimension of gravitational constant is this m is, if we take m, that is m to the power minus 1 L cube t to the power minus 2, m to the power minus 1 L cube t to the power minus 2. Okay. In this way we can determine the dimension of any physical quantity. Suppose we have to ask the dimension of coefficient of viscosity. Coefficient of viscosity. So we can know that the viscous force F is equal to, expression is eta, that is coefficient of viscosity, into area divided by velocity gradient. Now coefficient of viscosity is F eta equal to F dr divided by A dv, that is force into length by area into velocity. Okay, area into velocity. So force, what is the dimension of force? M L T minus 2, length L, area is L square, and velocity L by T, L T minus 1, L T minus 1. Okay. So if we write it, this L and L is L square, so this will be cancel out, and L square is cancel out. So M L to the power minus 1 T to the power minus 1, M L to the power minus 1 T to the power minus 1. Okay. So in this way we can find out the dimensional formula of any quantity. Suppose we have to give the dimensional of resistance. So at first we have to find out the dimension of potential difference, because we know the resistance is potential difference upon current from Ohm's law. Now we can see that work done must be equal to charge time potential difference, that is dimension of W must be equal to charge, that is dimension of AT A is ampere and dimension of potential difference is V. So, dimensional of V we can get W times AT. Now, W is equal to work done, that is force into length, ml T minus 2 into L, that is m L square T minus 2 divided by A. Here A is not area, A is, here A is A, is written as A, and this is written as obviously T. A is charge, ampere. So, we can get the potential difference dimension equal to m L square T minus 3 A minus 1. Now, divided by I. So, dimension of R equal to potential difference dimension, that is m L square T minus 3 A minus 1 divided by I means A. Okay. So, we can get dimension is m L square T minus 3 A minus 2. I hope you understand how we can derivative the dimension. If we know the dimension of potential difference, then we can dimension of capacitor, that is W equal to Q by V, charge time potential difference, and so any other equations. Now, we can go with the dimension of permeability of free space. Dimension of permeability of free space, that is the dimension of mu 0. Dimension of, what is the dimension of mu 0? When two wire carrying current, if their distance is L, carrying current in the same direction, one is I1 and I2, then the force per unit length between the wire must be given as this equation, mu 0 by 4 pi r I1 I2, that is mu 0 equal to F into 4 pi r by L I1 I2. From this equation you can easily find out the dimension of permeability of free space. That is dimension of F means ml T minus 2, 4 pi is constant term, r means the dimension of length divided by L, dimension of length, and I means A square, L cancel out. So, we can get dimension is ml T minus 2 A minus 2. ml T minus 2 A minus 2. We can also from this equation we can also find out the dimension of permittivity of free space, epsilon naught, from Coulomb's law, F equal to Q1 Q2 by 4 pi epsilon naught r square. So, we can go epsilon naught equal to Q1 Q2 times 4 pi f r square. What will be their dimension? Write in my comment box if you understand my lecture. For such lecture, please subscribe my channel and follow my videos on my YouTube channel. I am growing for a better result day by day on learning many things, as I am new to YouTube platform, but I am teaching experience is past 10 years, 17 years. So, please, if you like my video, subscribe my channel. Next day we will talking about the application of dimension analysis, which is very important for Neet, JEE and the obviously for the HS result. Thank you and keep watching my videos.